Everyone. So glad to see all of you here. So today, as we start to wrap up this wonderful three-day IoT conference, I wanted to look forward a little bit in terms of what is happening across our industry and some of the trends that are going to shape very much the solutions that we implement, as well as how do we start to practice IoT and develop the technologies that support a lot of these practical types of solutions. Now, as we think about this space, I want to pick up on three big trends that are starting to happen across our overall industry, because these three trends are very big in and of themselves. But as I want to talk about through our conversation today, I believe that these three trends are fundamentally going to come together and drive a lot of new innovations from an IoT standpoint that are going to both change how we have to think about how we implement IoT solutions, as well as what are some of the considerations that we have to start to practice, especially from a security standpoint. And the three trends that I want to focus on today are, first, the consumerization of IT. You know, this is something that we all live and breathe today, and we experience in our daily lives. But what does the fact that IT is starting to be consumerized have to do with IoT, and what are the impacts that it's going to have across our industry? Second trend that I'm going to focus on is the digitization of OT. As we start to digitally connect everything and add digital capabilities to all these different devices and controllers and so on across our infrastructure, what is the impact of that going to be? And finally, as we're seeing all these three different things start to converge together around IT, OT, and IoT, how is that going to influence the shape of things to come, and what are some of the solutions that we're going to have to implement as we go forward together? So I'm going to dive a little bit into each of these themes, just explore with you guys, what's happening from an IT perspective, what's happening from an OT perspective, and then as we consider that from an IoT perspective, what does that mean for us as we look to implement these solutions? So let's go ahead, and we'll go ahead and start with the consumerization of IT. Now, as we think about the consumerization of IT, this is a theme that's been around for a number of years now. As we start to take a look at the move of IT from a back office functionality into something that starts to drive digital business and digital transformation and digital touch points for our customers, we see that as radically impacting the way that we build our applications and the way that we practice IT itself. Now, perhaps the best example of this is around the mobile space. Now, all of you here, we're at an IoT conference, so I know that all of you are carrying around at least one smartphone, most of you probably multiple here at this event. But if you think about the way that mobile devices have started to change the way that we interact with businesses and with our IT systems, it's had a dramatic impact. I'll come to talk about the technology standpoint, but even if you just think about it from a business standpoint, there was a recent survey that looked at as enterprises started to adopt mobile technologies from a back office standpoint, as well as for how they engaged with their customers, what were some of the returns that they started to see across that investment. Now, one of the big changes that they saw was, yes, as you start to roll out mobile technologies, your customers like to use these technologies more and more. You get more frequent visits, you get more frequent interactions, and that definitely starts to drive up new revenue. So on average, across the entire industry, people who are starting to deploy mobile applications, they're seeing increased services revenue up by about 19%, new sales, brand new sales up by about 13%. But that's not the only win, and arguably that's not even the really big win that you get from implementing mobile. One of the perhaps surprising things was that as you start to employ mobile technologies, it starts to increase dramatically the productivity of your own workforce. And so this is due to a couple factors. One, your employees typically like to use their phones much better than the archaic enterprise systems that they have to access across their laptops. And so they start to leverage these systems much more frequently than they would have otherwise. And so it starts to increase dramatically the productivity of these workforces, and it makes your workers significantly happier. And so you're starting to see across the board increase in terms of productivity, in terms of sales, from the adoption of mobile technologies, from the consumer space now penetrating into the enterprise market. But that has a big change once you start introducing mobile change into the enterprise in terms of, well, how are you going to implement IT architectures and applications? Because if you think about the impact of mobile compared to your traditional enterprise application, when you go ahead and access your traditional IT system over a browser on your laptop, think about what that looks like. It's typically very transactional. Maybe it gets updated every 18 months, every 24 months. It's very locked down in terms of what it can provide you, and most people are pretty unhappy with these kinds of systems. Now, think about when you go home and you as a worker go home and you have your own personal IT department every single night. You download an application on your phone, it's instantly there. If you don't like it, you just delete it and you download something else that you like. Think about how frequently you're updating the applications on your phone. You get these little update notifications, multiple every single day, and how quickly all these applications are updating. And that's the new expectation that's bleeding over into the enterprise side. And that changes everything that we have to do in terms of how do we architect the infrastructure to support the applications, how do we build the applications themselves, then how do we deliver them to market. So first off, if you think about time to market, this 18 to 24-month update time for new software products, new software releases, implementation, and then massive rollout, we've got to shrink that dramatically. If we're going to do that, we need to put in place some new systems to do that. First off, we need to adopt a new infrastructure platform that's going to be distributed and scale out to support much more frequent interactions from our users than they've had to deal with before. We're going to have to move from a transactional architecture into something that is much more interactive and responsive. So something probably more on the likes of microservice architectures across a cloud platform. Think about how quickly we have to release these new applications. Instead of these long lead times, we're going to have to be able to push out updates very rapidly and very securely on a much more frequent basis, both to keep up with rising customer demand, as well as to stay competitive with what other companies are doing across this mobile landscape. That means you're going to have to adopt new practices like DevOps in order to be able to speed up the time in which you release your applications to market, and which also you get the quality of the services that you deliver. And finally, you're going to have to design brand new user interfaces around everything that you do. You can't just take an HTML5 wrapper around your existing enterprise application, drop it onto a mobile phone, and think that people are going to be happy with it. You're going to have to redesign the entire look and feel and engagement model of all these applications. So just the simple fact that we're rolling out these mobile applications into the enterprise space dramatically changes everything that we do from an IT perspective, from how we design our infrastructure, how we design the security around it, how we design the networking around it, how we design the application architecture, all the way to the user experience. And in order to do that, enterprises are now starting to adopt all sorts of new kinds of technologies and platforms in order to deliver on this consumerization. Just one example that we have at Red Hat, we have a mobile application platform designed to help enterprises deliver a lot of these new mobile experiences. Because when you think about all those things that I just spoke about, well, how are we going to deliver this new kind of architecture? We need brand new services in our back-end cloud, things that start to power things like, well, how do I deliver a push notification securely? How do I provide geolocation services? How do I provide connectivity and analytics services, and so on? You need to be able to have the ability to write user interfaces natively for iOS and for Android and for other clients. And how are you going to be able to consume all those without having to have different development teams working in parallel? And finally, you need to be able to apply DevOps, as I spoke about. So how do you start to develop your application with your operations team in a collaborative environment? How do you roll that quickly into staging and into production, leveraging tools like continuous integration, continuous deployment, and so on? And that's what our mobile platform is designed. It gives you that back-end set of services, so all the APIs and services to power your mobile applications. It gives you that interactive platform, entirely cloud and web-based, so that your developers and your designers and your operations teams can work together from inception all the way to deployment. And it also gives you those development tools so you can write your application once and deploy it anywhere. But these are the kinds of changes in technology that are starting to drive consumerization from an IT standpoint. And it's not just about how do we adopt new different technologies from the back-end standpoint to be able to build these, but it also changes very much what the shape of the applications look like themselves as well. Let me give you an example of that. Now, one of our customers that's been working with us and using our mobile platform is from my home state of Massachusetts. I live in Boston. And so Bay State Health is a big healthcare network across my home state of Massachusetts. And they wanted to start to digitize their services and provide a lot of new capabilities, both for their patients as well as for their healthcare providers. And they wanted to build a new mobile platform to do two things. First, they wanted to build out a system for their doctors and their nurses so that when they were working with their patients, instantly on their mobile devices, they could get patient records. They could link it to research and information around what might be possible treatments, what might be possible ailments that you should think about, so to help them become much smarter in terms of how they can deliver that proactive care. The other thing, though, and this is what is interesting to me, is that they wanted to help connect their patients into their network using their mobile phones as well. So one of the tools that they built out was an app around remote diagnosis. And so if you wake up in the middle of the night and you're not feeling well, instead of having to take a midnight trip over to the emergency room, you can pull up their mobile application. You can do a live video of yourself, of here's the symptoms I'm feeling. I can send it over to my doctor, and he'll tell me, OK, you better come in, or this is nothing you need to worry about. Make an appointment, and I'll see you in a couple days. Dramatically improved the quality of care as well as the lifestyle for their patients. Now, if you think about that, you think, wait, all I'm doing is sending live video? What's so big about that, right? No, that's just Snapchat or Instagram Live for those of us over 22. So if you think about these kinds of services, though, from an enterprise standpoint, it intersects with all those different requirements that I spoke about. Because think about when you're delivering live diagnosis. That has to integrate with all the patient healthcare records, so that gets recorded. It has to be compliant with all the patient security regulations from the government and HIPAA and all these different things. It's got to be able to plug into the enterprise back-end systems across all these healthcare providers, not just at one hospital, but across a hospital network. And so when you think about how that is impacting the development of the overall IT network, of the development of the application teams, and also the delivery process, you can start to see that this consumerization of IT is having dramatic impacts in terms of how do we deliver these applications, and it's changing what IT looks like. When people talk about the convergence of IT and OT, you can't talk about what IT looked like 3 years ago. You have to look at where is IT going, and how is that going to shape IoT. We'll come back and we'll pick up on that theme. But the second thing I want to talk about now is the digitization of OT, because this is the second big trend that is going to start to affect how we start to practice IoT and how these things start to come together. Now, as we think about OT, I want to start with an example from one of the most canonical industries that we have to deal with, very emblematic of the entire industrial revolution and the industrial age. And that's from the transportation industry, specifically around railroads. Railroads are what connected back in the late 1800s across the United States, for example, from the East Coast to the West Coast. It's what powered all that growth around the Industrial Revolution. Now, in the United States, one of the projects that Red Hat's been working with a customer, MeteorCom, is around a project called Positive Train Control, or PTC. A few years ago, there was a very catastrophic train accident in the US. And in response to that train accident where there was a collision, the US Congress passed a law mandating that every single train would have to implement what was called PTC, or Positive Train Control. In effect, you had to have remote sensors on every single train and on every single station, so that if a train approached another train too quickly, if it approached a station too quickly, it could be remotely controlled and automatically slowed down to prevent an accident. So this was mandated by law that every single railroad across North America, in cooperation with Canada, would have to implement this system. And MeteorCom was basically the corporation created as a consortium across all the railroad industries charged with implementing PTC. So I get 45 seconds added to the clock, right? So anyway, as I was saying, MeteorCom is the company that's been charged create this positive train control system. And they've been building this entire system on top of Red Hat software. First, across every single railroad, as well as every station, they're putting these little computers powered by Red Hat Enterprise Linux with our middleware technologies on top, especially for the communication networking. They've created this wireless mesh network that goes across all the different railroads and all the different stations, runs on a proprietary network so that you can safeguard it from attacks, and so that it can be optimized to go over a lot of the tunnels that the trains have to travel through, or all the different environments that they're going to go through, and how does it work very robustly across that. Now, one of the things that we've been most proud of at Red Hat is that as a result of this system that as they've gone into production, they've been able to maintain a 99.999% service level agreement across this PTC network running on Red Hat software. And this is hugely important because we're dealing with lives, right? We're trying to prevent catastrophic accidents from happening as trains approach other trains so that they don't collide. And we're very, very happy with this, and this is a statistic that we're incredibly proud of, and we're incredibly proud to partner with Mediacom on the delivery of this system. But one of the things that's happened is that as the railroad industry has started to deploy the system, they've run into a number of massive delays. In fact, they've had to push out the implementation fully nationwide of PTC out currently to 2018. We'll see if it actually makes that. And that's unfortunate because this is just news from about a year and a half ago. There was a big, massive accident in the Northeast Corridor in the US where one train collided with another train. And one of the big conversation points was, could positive train control have prevented this accident if we had been faster to deploy the technology? The trains were already lit up with the servers on board. It's just that the system wasn't activated because the railroads weren't able to put in all the systems in terms of being able to implement PTC across how they manage everything. And this is one of the big challenges that we're going to face as we deal with the digitization of OT. We're used to being able to deploy systems that live in the field out for decades or more. And so if you've got a delay of 6 months, 12 months, 18 months, it's something that you can live with. But digital technology moves at a very, very fast pace. And if you don't start to increase the speed at which you start to practice your OT practices, you start to get this impedance mismatch between the speed at which digital technology is advancing and how you're going to start to implement it in the field. And the challenge for that is when you have this impedance mismatch, you're going to start to end up with hopefully not as catastrophic a case as this, but oftentimes challenges in terms of how do you start to implement, especially IoT solutions as we move towards the future. Another example, so we're starting to connect all these different power plants. We're building out smart cities and stuff. And power plants are another thing that we've had since the Industrial Revolution. Each one is massive. It powers a city, sometimes broader than a city, depending on the network it's connected to. But it's a very finite, very, very massive piece of equipment that we're using to be able to provide power to a certain set of resources across a national or a state or a city grid of some sorts. And one of the things that's happening is as we start to digitize, even at the power plant level, and people start being able to generate electricity from their homes, as we take a look at all these use cases of being able to trade energy, sell things back to the utilities, sell things back to each other, now you're going to have to deal with a scale of operation and, again, a speed that you haven't had to deal with from an OT side. And it's not even just about scale in terms of sheer numbers. It's scale from the standpoint of before, you were in total control of every single device that was placed out there. Ideally, you had good inventory of what was going on, and you knew what was being implemented. When you have all sorts of other actors and devices joining the network that you've put in place, how are you going to manage that? How are you going to make sure that it's secure? How are you going to be able to operationally control all these different things? They're all working with different hardware specifications. They're all working with different owners, different interests. How is all that going to combine together? As soon as you digitally start to connect all these different pieces of infrastructure that weren't necessarily designed to do that in the first place. And we've seen already some of the effects. This is a case that I'm sure all of you are very aware of. It was big, big news, but the attack on the Ukraine power plant that happened late last year. Now, I don't know if you read all the details. This is a very, very sophisticated attack. No, not only did they attack all the computer systems, so they took down the monitoring system so that they couldn't see what was wrong with the power plant. They took down all the control systems from a computer standpoint so that you couldn't go ahead and easily fix what was going on from a computer standpoint. They even launched a denial service attack on the telephone systems so that as people were trying to respond and figure out how to coordinate together, they couldn't talk to each other on the phone. But these are the kinds of attacks that you're going to have to start to deal with. Very, very sophisticated integration of IT and OT technologies as they start to converge, but also the digital speed and scale at which you're starting to deal with once you start to hook up everything from an OT standpoint. And so these are some of the trends that are starting to pick up. We've got the consumerization of IT. So when we talk about convergence of IT into OT, it's not the IT of 3 years ago, 5 years ago. It's all these new technologies that are driving fundamental changes from our back-end infrastructure all the way to how we deliver applications with practices like DevOps. When we take a look at the digitization of OT, it's all about how speed and scale and security are being magnified in a way that we haven't had to deal with before. And now these things are going to start to converge around IoT, and what does that mean for us? First thing that's starting to converge around IT and OT is that life cycles are going to start to converge. I mentioned on the IT side, before with enterprise applications, we typically had an 18-month to 24-month window before we updated our applications, rolled it out, and then had time to do POCs, to do staging environments, to be able to deploy that. All that is going away. So now we're going from a year and a half to oftentimes a week and a half before we have a next deployment. This is where you start to see a lot of practices in DevOps for things like continuous deployment, all these automated systems that can flow from development all the way into production, and how do you make that flow very, very efficiently. Same thing from an OT standpoint. I gave the example around PTC, around how we have this tremendous need now to speed up the delivery of an OT system based on the fact that it is becoming increasingly digital. And so you're going to start to see these deployment times and lifecycle times where things would live out in the field for 15 years, and now you're going to have to be changing them every month and a half or so, because once you start to deploy a 15-year-old digital technology, it's pretty useless as technology moves on. And so it's going to have dramatic impact in terms of what are the things I'm going to have to deploy out in the field, how in the world am I going to manage the life cycle of these different devices. Second thing that's going to start to converge, technologies are going to start to converge. This is the 10-year anniversary of Amazon AWS, and arguably the world's first infrastructure as a service public cloud. Up here, I'm just showing you for a little bit of fun. These are the first virtual machines that were available in the public cloud when AWS launched 10 years ago. And if you compare the hardware specifications of those first VMs in the public cloud with what you can run on a mobile phone or a gateway or even a Raspberry Pi, you'll find that all the devices now that we talk about as low-powered, they're actually much more powerful than the entire compute capacity that you could go ahead and get in the public cloud just 10 years ago. And this is the pace at which we're dealing with. As Moore's Law advances technology, as other technology advances start to increase the available computing power on these edge devices. They're going to get much more powerful, even from the gateway to the edge devices. And that's going to create a new class of software and infrastructure and application architecture that is going to push out to your edge devices that used to live exclusively in the back end. Because we fast forward another 10 years. Think about all the things that you can run in the public cloud today, and imagine all those running on your phone or on a little smart device. That's the world we're going to move into. And you have to think about how do we design applications that live in that world, where you can have the power of today's public cloud in 10 years' time, tomorrow's smart devices. Totally changes the way you think about your application architectures. One of the things that we think is going to happen is that as a result of this technology moving at such a rapid pace out towards the edge, is that architectures are going to converge. Now, today, we often talk about this three-tier architecture around IoT for enterprises and industrial use cases, where we've got our back-end data centers, whether your own data center or in the public cloud somewhere. We've got these smart gateways that start to provide some computing capability close to the edge. And then, of course, we've got the smart devices. This is largely an artifact due to current hardware limitations. But as I pointed out, those hardware limitations are going to start to go away. And that means this architecture is going to start to blend together. And so you aren't going to have to think about what are the things I exclusively designed for my back end, what are the things I exclusively design for my front end. But you're going to want to have software architectures that can run consistently across the entire architecture, whether in your back-end data center or whether on these devices, because the computing platforms are starting to merge together. And as I spoke about before, the delivery processes are starting to merge together, whether you're building a back-end IT system or whether you're moving towards your OT systems closer to the end. So what does that mean from a software architecture standpoint, and how are you going to start to blend all these things together as life cycles and application architectures start to converge? Well, one of the things that we've been focusing on Red Hat is how to give you a lot of these consistent software building blocks that can run end-to-end from the back-end data center to these gateways all the way to the edge devices. And we're already at the world where we can run largely the same software stacks from one end to the other because of the rapid advances both in software as well as the rapid advances in hardware. Let me give you one good example. A lot of you who are coming from the IT side, you will certainly be familiar with all the hype and the buzz around this technology around Linux containers, Docker, if you will. Now, one of the things that Linux containers is really good at is that it starts to help us slim down the operating system to a very, very small footprint. It also makes it much easier to deliver payloads onto the operating system using this container technology. We have built in container technology natively into our operating system, Red Hat Enterprise Linux 7. We also have a variant of Red Hat Enterprise Linux optimized only to run containerized workloads called Red Hat Enterprise Linux Atomic Host. But with this single operating system, now we can deliver a very, very small footprint OS that can go across all these different tiers. And the benefit of standardizing on that one piece of architecture is not just the fact that I have an operating system that runs consistently. It's the fact that all the practices that you can apply from your data center now can apply to your entire IoT footprint. So, for example, when you think about security and a lot of the capabilities that we deliver into the data center, now we can extend these to your gateways. Now we can extend these to your devices as well. One of the great advantages of containers and Red Hat Enterprise Linux is that they provide isolation for your host. And so we can protect applications from each other. So if you've got two different containerized workloads side by side, there's a huge amount of work that Red Hat's put in to how do you secure these applications from working within and across each other, as well as with other devices across the network. There's a huge amount of work that Red Hat does in terms of securing the provenance of how updates and how packages and how content are delivered into the operating system. So tracing all the way from source code all the way to deployment across your OS. This is something that becomes important, not just in your data center, where we've had that for 12, 15 years, but it's hugely important now as we take a look at gateways, as we look at devices. Just think about all these attacks that we've been reading about in the news today, and it's for this lack of ability to be able to update with a lot of the traditional operational tools across these new classes of devices that leave us so vulnerable. And so having the fact that we can build on a common building block that works across all these different devices becomes hugely important. And it's not just at the operating system level. This goes all the way up into the operational management space as well. So, for example, we've got different tools at Red Hat for managing your deployments of your software. Tools like Red Hat Satellite, which help you deploy and provision your operating system at scale across thousands and thousands and thousands of servers or devices. We've got tools like our CloudForms management platform, which provides you with introspection and policy and monitoring across your whole infrastructure. These are tools now which you can apply not just to your back-end data center, but because we can run that consistent software fabric across your gateway all the way to the edge devices, we can extend the view of what is happening there. Linux containers on the bottom across that entire footprint, common management tools. And so now when we think about how in the world are we going to deal with these operational updates, if there's a security patch, how do I push it out to these devices? If there's a new update that I need to push out because I need new functionality across my systems. Even just think about as your developers are building their applications. From an IT standpoint, we finally reached a world where developers can go to a cloud and they can get self-service provisioning to a virtual machine or to a container so that they can build their applications. It used to take weeks and weeks, if not months, to be able to provision a brand new developer kit for developers to be able to write their first line of code. Now in the world of IoT, we've reset that. Are we going to have to give out new hardware kit for every developer before he can start to write his application? Well, if you can standardize that software platform, you can take that same Linux containerized platform from Red Hat, you can run it in the public cloud, but now and do your development there, but now I can deploy it onto a gateway or even onto an edge device. So that portability gives you huge, huge wins from a productivity standpoint, even as you write these applications. Now, as we take a look at the Red Hat portfolio, you can see this up here. We've got a pretty comprehensive software portfolio that goes from the data center all the way to the devices. Everything from our mobile platform, which I spoke to you about, Red Hat Enterprise Linux. We've got a very comprehensive middleware technology stack around our JBoss middleware. So things like application servers or messaging middleware. We've got software-defined storage systems that can go ahead and distribute storage across commodity servers and commodity platforms. Our management tools like Red Hat Satellite and so on, and our cloud platforms like OpenStack and OpenShift. And the OpenStack conference is going on down the street this week in Barcelona as well. Now, I spoke to you about the fact that all these things are going to converge. What you see up here is right now, how is Red Hat able to address all these traditional 3 tiers of an IoT architecture between data center, gateway, and devices across the current solutions that we have. Now, if you take a look at this, you'll see that a number of our technologies already span across that due to this convergence that's happening. So we can take our mobile platform and address this entire span from data center all the way to your edge device. Our Enterprise Linux operating system, I spoke about the fact that we can run it as your trusted operating system in the cloud, but we're also putting it on gateways, and we're also putting it even on edge devices. That's already being done. Our middleware technologies, so things like our messaging services, where we can go ahead and put on your edge devices, MQTT messaging client, and then we can speak to our JBoss messaging server, AMQ, sitting on a gateway, and then we can broker that back into your data center, speaking another protocol, maybe AMQP or something else that is native to what your data center speaks. All that is already being done today, things like our business rules engines. But as we move up to some of these cloud platforms, things like OpenShift, which is our container application platform, things like our storage servers, which certainly aren't running on edge devices yet. My prediction and our goal at Red Hat is to drive this all the way across the board so that this fills out over time. Because as I spoke about, 10 years later, the public cloud of today is going to be the power of tomorrow's edge devices. And that means that we can start to fill in this chart comprehensively. And that's going to change everything about the way that we build applications at Red Hat and how we think about delivering our software. But it's also going to change how you start to implement your solutions and start to define them. Now, I want to close with one more example. So I had spoken to you earlier about the fact that we've been working with the railroad industry around positive train control, and this was a really, really good example for us of being able to work with the railroad industry. And unfortunately, due to the inability of the railroads to implement quickly enough, we're still having accidents in the United States today. One of the other vendors that we started to work with in the PTC space is this company called Herzog Technologies. And this is an interesting solution towards how do we get to a faster deployment of IoT solutions, especially for the railroad industry around PTC. Because what Herzog Technologies is doing is that they've built a new SaaS-based offering around PTC, software as a service, hosted entirely in the cloud. Now, this is a solution that they're offering to especially a lot of the smaller railroad operators who don't have the sophistication or the knowledge or the skill set in-house necessarily to be able to deploy and build out and the integration of the train's PTC systems into their own operations of trains. And so now they can go ahead and consume from Herzog directly a software as a service where they can go ahead and manage all the PTC going across their networks, going across their vehicles, and across the corridors that they happen to own. It's software as a service, so it makes it really easy for them to deploy. And this entire system is, again, built on top of Red Hat technologies in the back end. And so leveraging things like our CloudForms management platform to give you Okay, as I was saying, so they've been building out this entire cloud system on top of Red Hat technologies in their backend data centers. So things like our CloudForms management platform to provide the orchestration and the self-service provisioning of the entire software stack as they make it available to their customers to be able to consume. And this is hugely powerful and hugely valuable, and it sort of illustrates this convergence theme that I've been talking about. Because with MeteorCom, what Red Hat did was we put in all the devices, and we put in all the mesh networking across all these different trains and all these different stations. And now we're linking that exact same technology platform, Red Hat Enterprise Linux, the same management tools that we're managing all the trains, it's managing the systems here for Herzog in the backend data center. Identical software tools, identical operating system, identical platform. And this is the kind of convergence that we're seeing across the industry. The fact that even in a railroad industry, that you can now start to deliver back-end solutions to accelerate the implementation of PTC with cloud-based solutions on Red Hat. The fact that on every single train is a little bit computer, a little bit device running Red Hat operating systems and middleware connecting everything together, and that all these systems talk together and work together with the same operational model, the same technologies, the same security, the same deployment models. This is what is going to drive that consistency as we start to go forward from an IoT standpoint. And so this is the kind of convergence that we're going to start to see play out in our space as we start to see the rapid consumerization from an IT standpoint, the increase in digitization around IT, OT, and how all these things all start to come together around IoT. So with that, thank you very much for coming. I hope that was useful for you. I'm happy to take any questions. And if there are no questions, I highly encourage you to check out our booth here. We're doing some really cool demos across our IoT capabilities and some of the partners that we've been working with on their gateways and their devices, and how we can show you in real time a lot of this convergence that I've been talking about here. But you'll get a real-life demonstration of that at our booth, as well as a Fedora if you're lucky. Okay, looks like we have no questions. So thank you very much.